Oh, okay. Discovered. All right, so we're going to start in the 7th grade section 5.1, which is titled Ratios and Rates, but we're specifically focusing on unit rates, something you did last year, but we're going to talk about again this year. A unit rate is a rate with a denominator of 1. Sorry, the blue arrows are still in your notes there. I didn't erase those. Those are examples of unit rates. This is an example of just a rate that's not a unit rate. 60 miles in 2 hours is not a unit rate because the denominator is not 1. However, if I reduce that or just divide it, 60 divided by 2 is 30. 30 miles per hour is a unit rate. That's why we use unit rates. Unit rates are easy to compare. If someone said they traveled 400 miles in 6 hours, and another person traveled 500 miles in 6 2/3 hours, that's hard to compare. But if they said I was going 66 miles an hour and the other person going 65 miles per hour, we could definitely compare that a lot easier. That's why unit rates are so easy. For example, this snorkel over here is 875 per hour. This is 725 per hour. I know which one I'm running. Unless it's just cheaper because it's lower quality. That's something you have to consider, right? But yeah, if everything's the same other than the color, I'm going for the red one because it's cheaper. Right?
Red is a better color anyway.
No, it's not.
What is your
Now,
sharks in the water? The sharks like red.
If you would have said that one of them was $37.85 for 4 hours and the other one was $32.25 for 3.5 hours, again, that why would they do that, first of all? And secondly, I wouldn't be able to compare it until I find their unit rates. So they're easy to compare. To find a unit rate, you have to divide the same way you would divide 60 divided by 2 to get 30 miles in 1 hour, 30 miles per hour. And then you also have to label. Unit rates have 2 labels, not just one. Miles per hour, miles per gallon, dollars per can, dollars per pound, teachers per bus, servings per package, calories per steak, fries per container, pieces of gum per desk. That's more like it. Okay. All right, let's start by finding these unit rates. You run 84 meters in 8 seconds. What is your speed? What is it, Xander?
12 meters in 1 second.
12 meters per second.
That's not right.
Okay. Now, when you abbreviate, and I'm all for abbreviating, M is the abbreviation for meters. It's not the abbreviation for miles. Miles is MI. SEC is the abbreviation for seconds.
Yeah.
Did you not divide it correctly, Xander?
Oh.
What is it?
10.5.
10.5. Thank you. Here I was thinking, maybe I should get my calculator out so I'm not giving wrong answers.
I thought it was going to be a multiple of 12.
Okay.
I was just taking it from wrong one.
So does everyone agree on 10.5? Okay. Yeah, you'll want a calculator because you're going to be doing division today. And then my label is 2 meters per second. The slash stands for per. Now, there are some abbreviations that I would be okay with using a P for, like MPH stands for miles per hour, MPG stands for miles per gallon. Those are really the only 2 that are universally known. If you used MPS, not everybody knows that that's meters per second, so go ahead and use the slash. The only 2 that I'll accept MPH or the P on is MPH and MPG, miles per hour, miles per gallon. Everybody knows. You see car commercials all the time. They talk about speed. They talk about the miles per gallon. So meters per second, we would put M/second. Well, then you would be using meters, wouldn't you?
We should just switch to like the normal.
You pay $27.98 for 7 pounds of grass seed. Sky, what is that unit rate?
$4 per pound.
$4. Is it exactly 4?
No, I rounded it. It's $3.99.
$3.99, but the next digit is a 7, so it is, you're right, you would round to $4 per pound. The abbreviation for pound is LB. I don't know, I think it has something to do with the Latin root of that word.
Oh,
But,
everything has to do with Latin. Oh,
okay, so if you didn't hear what Sky said, she said that when she divided, she got 3.997. since we have to use 2 decimal places with money, we have to look at the 3rd decimal place, but because it was a 7, it's gonna bump everything up to $4. And then example C, you traveled 440 miles in 8 hours. Carson, what's that unit rate?
The unit rate of 440, MPA.
Yeah, what'd you get?
Like, or 440 PA. Hold on. Okay,
Did you divide them?
no, I did not.
Okay, let's do that first.
Yeah.
We will use MPH. You're right, miles per hour. You can write it like that, or you can write MI/H, but MPH is pretty well known. What do you get for 440 divided by 8? 55.
So the word pound comes from the ancient Roman when the unit of measurement was libra ponto, which is the pound by weight.
There you go. So Roman, so not Latin, it would have been a Roman. So
Romans
a lot
speak
of their
Latin, though.
language, yeah, I was gonna say, a lot of their language though was Latin based. Okay, anyways. Move on to the next one. Now, this next one is actually a problem in your homework. So what we're writing on your iPad right now, we would also want to write down on our work paper, because I believe in the homework, it's a multiple choice. And I'm not gonna accept just putting A, B, or C down without any work. So it says, a sports store sells 3 different packs of tennis balls. Which pack is the best buy? We're going to determine that by finding the unit rate.
Can I go with the most, actually, no, the middle one. My bad.
Middle one?
You can do the last one, Brady. Brady, I need you to tell me how many in that last grouping right there, how many packs of tennis balls are you getting? 9. So you're going to do $22.99 and divide that by 9 packets. I'll let you do that. And Martin's going to do $16.79. But Martin, how many packs are you getting for that price? 6. So divide by 6. And Julia, how many packs are you getting for $11.49? 4. So divide that $11.49 by 4. And we're going to compare what our unit prices are. Brady, what did you get for the large packet? How much are you paying for that?
$2.55 per pack.
Okay. And it wasn't exact, but you rounded, correct? Okay, $2.55 per pack. And Martin, what did you get? $2 and what is it? 80 cents. Okay, so that one's going to equal $2.80 per pack. And notice how I'm not just putting $2.80, I'm actually writing per pack. So I don't get the bad habit of only labeling with one label. I have to use 2 labels for unit rates. And then Julia, what did you get for your $11.49 divided by 4?
$2.
Per pack. Yeah. So that's what you would write on your work paper, because now you have each of those unit rates. And now we can see that the bulk pack, the $22.99 package where you get 9, is actually the better buy, which is why stores like Sam's Club and Costco exist, because even though it is more expensive, you're getting more for that money than what you would if you just bought the $11.49 pack. So if I'm loading up for tennis balls for the season, I'm going to, instead of buying a bunch of these, I'm going to buy fewer of these because I'm getting more for my money. Okay. If I only need a few, I'm not going to buy in bulk. I'm not going to go to Sam's Club and buy the cereal box that has 4 bags of cereal in it if I don't eat cereal that often, right? So I'm saying, yes, it's cheaper per package, but only if I'm going to use them all. Okay. Don't go out and just waste money.
Then you have like cereal for the rest of your life.
Cereal gets stale.
Okay. So now we are exiting section 5.1 and we're moving into the 7th grade 5.4 section, which is over proportions. A proportion is an equation. So it has an equal sign. It's an equation stating that 2 ratios or fractions are equivalent. 2 quantities that form a proportion are said to be proportional. So the way I would read this isn't 2/3 equals 4/6. Well, if I knew they weren't ratios, what I would say instead is that 2 is to 3 as 4 is to 6, because it's a ratio here. Okay. You could think of them as fractions. Ratios pretty much are fractions, but we could also write it like this. And we could write it like this. What's that sign called? Sander?
Semicolon.
Not a semicolon. That's a semicolon. That's a comma there.
Oh,
This is a full colon, just a colon. Yeah, this is a colon. So you can write ratios like that as well. So if you see that, just know it's the same thing. You can turn it into a fraction very easily just doing that, what they did up there. So in a proportion, A over B equals C over D, the products A times D and the product B times C are always equal if it's a proportion. Meaning if the two ratios are equal, their cross products will always be equal. And if you do cross multiplication and you get two different products, then it never was a proportion. They weren't equal at all. So one of the sections that I'm not making you redo is the 5.2 section where you use cross products to determine if they are proportional. We're going to assume that all of ours today are, and we just have to find the missing value that makes them proportional. Okay, so we're going to use cross products today. You guys remember using cross products last year? So cross products. 7 times A is equal to, because it's a proportion, so I know the cross products are equal, is equal to 5 times 21. Seth, what's 5 times 21? Connor, could you shut the door for me, please? 105. Get this nice, easy one-step equation that I can solve. And Alex, what do you get when you divide by 7? Oh, he didn't take the hint when I said get your calculators out. Make sure you have yours out too. What is it? 15? Okay. Notice how it says A equals 15. They are equations, and so you still have to put the variable in your answer, even if you're on your work paper. I know that they've already got A equals written on big ideas, but go ahead and write it on your work paper, just like you did when we did our equations. Example B. B times 10 is 10B. 8 times 7 is, anybody? 56. Divide by 10. 5.6. You don't even need to use your calculator for that. Dividing by 10 takes the decimal point and it slides at one spot to the left. Timesing by 10 slides at one spot to the right. So 5.6. Now, every year I get people that say, Mr. Bright, I don't need to write down all that work because I know you just multiply the two numbers that are diagonal to each other and then divide by whatever one's diagonal from the variable. I don't know if you noticed that or not, but that's exactly what we're doing. You always multiply the 5 and the 21 and you end up dividing by 7. You multiply the 8 and the 7, you end up dividing by 10 until you get to problems like C and D. So this is why actually writing them down is beneficial. We're not going to change anything. We're still going to use cross products here. But what's 10 times 3C? Sky? 30C. Yeah, so I can't do 12 times 15 and divide by 10 and get my answer because there was a 3 next to the C. So that's not going to give you the right answer. So it's 30C. What's 12 times 15? Garrett? Christian, sorry. Christian? 180. And Christian, go ahead and divide by 30 and tell me what you get. C equals 6. And example D. Yeah, we're still going to use cross products. We'll still use cross products for this. Now, here's what I have to do differently here. The 3 was being multiplied to the C. So when I do 3 times C times 10, I can just say 3 times 10 times C is 30C. Here, the 1 is being added to the D. So what we have to think about is we have to assume that when we're multiplying this, assume the 15 has to be multiplied to the D and the 1, and the D plus 1 was in parentheses. If you thought about it as being in parentheses, what would you do now? Jimmy? Yes, yeah, you would distribute it to both numbers in the parentheses. So whether you want to write it that way or not, you still have to distribute it. So 15 times D, Jimmy, is, and 15 times 1? Yeah. So what I would do is I just kind of, you're still cross multiplying, but you're taking the 15 to the D and to the 1. Okay, like as if you're distributing. Now, what's 40 times 6? Anybody? Go ahead, Deegan.
Well, 240.
240.
Do the 40 times 6 to get 240.
And subtract 1, and that's exactly what we're going to do here. This is in a different order than what you said. Yeah. So ultimately what happens is in a problem like this, instead of getting a one-step equation, a one-step equation, a one-step equation, I get a two-step equation because there was an extra term there. Okay. So we subtract 15. Deegan, what's 240 minus 15? Okay. And then divide by 15 and you get 15. Yep. And that's a coincidence, by the way. It just happens to be 15 because 15 goes into 225 15 times. So when you said subtract 1, that was because we hadn't times by 15 yet. So this is that subtract 1 step. We're just looking at 15 when we multiply 15 to it. Yeah. That works too. All right. Story problems. 5 movie tickets cost $36.25. What's the cost of 8 movie tickets? So in these problems, want to be very clear about this. You must set up a proportion on your work paper. On your quiz Friday, you will have a blank and an equal sign, and you're going to have to put those 4 numbers in there and set up a proportion. So here's what you would do on your quiz. It's going to look like this. The instructions on the quiz are going to say, set up and solve a proportion to find the cost of 8 movie tickets. So the first thing you'd say is, well, you paid $36.25 for how many tickets? 5. So I'm going to write 5. And I like to label, even if it's abbreviations, because when you set up your proportion, you have to make sure your labels line up on top and they line up on bottom. So if you put the labels there, it makes it easy to line them up. Where does that mean that I have to put the 8 tickets in the next ratio? Jace, thanks for volunteering. Where should I put 8 tickets in the next ratio, top or bottom? Where the other tickets were, right? That would make sense, right? So we're going to say X dollars for 8 tickets. That is worth a point. And then we're going to cross multiply it to get our answer. So set up the proportion and then cross multiply. 5 times X is 5X. 36.25 times 8, 290.
Yeah.
Divide by 5. Divide by 5. 58. And what did the X stand for? Dollars. Another advantage to labeling your proportion is when you do find X, you know what its label is supposed to be. Now, would I be cruel to you and count off if you labeled it incorrectly?
Probably.
Yeah.
Yes, I would. Yes. So please make sure you're labeling all story problems, especially these proportional ones. Yes.
I did 36.25 divided by 5 times 8.
Okay, that works. That works, but on the quiz, it is going to ask you to write a proportion. Okay, just so you know. And so you have to get the points for that. What Lizzie has done, she said she took $36.25, divided it by 5. That gives her, as we just did in our last mini section, the unit rate. Do you remember what you got?
7.25.
That's right, 7.25. So when she divides by 5, that means she's paying $7.25 per ticket. Then she times it by 8 because there was 8 tickets you were buying, and that gives you $58, right? So you could also do it that way, but on the quiz, when it says set up a proportion, make sure you can do this. Make sure you can still set the proportion up. So I'm going to give you credit for that. You're riding on the AVE, which is a high-speed train connecting Madrid to Barcelona in Spain. Has anyone been on this train before? Oh, I have. You've been on this train before? Oh, have you been on a high-speed train before?
No, but we're not this.
On this train or just on a high-speed train in general? Do you remember where they were?
No.
They were they in? Okay. Okay. I don't know if the US has like any of the high-speed trains that Europe and especially Asia has, but it very well could have been. Okay. Europe, so Europe has a lot. So a lot of the travel in Europe is done by train. Okay, because all the countries are connected. Obviously, no, our states are connected too, but our train infrastructure is more for like traveling. They're transporting goods. Not a lot of people travel by train anymore, but it's cheaper than planes. So I guess people think it's cheaper than planes, especially when the trains go very fast. So this train between Barcelona and Madrid, I've been on this train before. It takes about 2.5 hours on a train ride, and you travel, I think it's 628 kilometers. Not per hour, but in total in that 2.5 hours, right?
I was gonna say, per hour. Oh my
When we
God.
finish this question, I actually have a video of the train. the train ride. I can pull
So
up here.
is this actual information on the question? or-
So I'm gonna give you actual information.
So we're not using these numbers?
We are gonna use these
We
numbers
are.
because the train does not travel at a constant rate.
Doesn't?
But in this graph, it does.
Okay.
It doesn't because the train's not going as fast at the start or when it slows down. So it's, you know what I mean? It's kind of curves, but since we're not doing curves in this class, they're basically saying, here's the average speed. So the average speed probably is this, okay? You're writing on the Ave, the distance traveled is proportional to the number of hours traveled. Now, tomorrow, we're gonna talk about proportional relationships. That's literally the section of tomorrow's homework. This says it's proportional. So you'll see a graph that looks like this in tomorrow's homework. All the graphs that are proportional will go through one point on the coordinate plane. It's always the same one. What's the very first point you ever learned? Jimmy? 0. Yeah, it goes through 0, 0. It's going to be a proportional relationship. It will have to go through 0, 0. Now, does every line go through 0, 0? No, we've done lots of lines that don't have a y-intercept of 0. But the ones that do go through 0, 0 are all proportional.
If you had, like, say, a y-intercept of 2 and both lines go through that, does that mean that they're proportional?
No, they have to go through 0. It's a good question, but they have to go through 0, 0. Now, because this one does, we can find what the unit rate is simply by taking one of the points that's on the line, except 0, 0, and dividing. For example, if this train travels 200 kilometers in 1 hour, that means it's traveling how fast? 200 kilometers per hour, exactly.
How much-
It is.
miles that?
We will convert that. We will convert that here in a second. Now, will I get 200 kilometers per hour if I use this point and do 800 divided by 4?
Yes.
Yes. Now, will I get 200 if I do 4 divided by 800? No, so the order I do the division matters. If I'm doing kilometers per hour, shouldn't I do the kilometers number first? What's the kilometers axis? Lizzie? The Y. What's the hours axis? The X. When you find slope, which one do you put on top? The Y, Y2 minus Y1 over the X2 minus X1, the run, right? There's a reason for that. Okay, that's, I wouldn't have taught you Y2 minus Y1 instead of X2 minus, like the reason that we do that is because we always put the Y on top.
Okay.
If the train keeps the same speed, how long would it take it to travel 505 kilometers? By the way, that's not the distance between Madrid and Spain. It's like 4/5 of the way.
Oh, wow.
So what I can do is I can set up a proportion. Now, it's not the only thing I could do, but I could set up a proportion. I could say, well, if it travels 200 kilometers per hour, I can write that unit rate. And the reason I want to do it this way is because I want to remind you that unit rates have a denominator of 1. So if it travels 200 kilometers in 1 hour, it'll travel 505 kilometers in how many hours? Cross multiply. Now, most of you, when you're solving this problem, would not have cross multiplied. You would have thought, am I multiplying or am I dividing here? And you would have figured it out. And we could still do that. But the cross products means I'm actually taking the guesswork out of it. I don't have to guess. I know that 200 times X is 200X. And I know that 1 times 505 is 505. And that means actually, if you were thinking I should divide these numbers, you were right. It's 505 divided by 200 because I need to know how many 200s go into 505 because that's how many hours it would take. So what is 505 divided by 200? Seth, you have your arms crossed. Maybe you should calculate this. But because I'm cruel, I'm going to call on Shane instead. What is it? 2.5. It's not perfectly 2.5 though, right? 2.5 to something. Okay, so we'll round it. We'll say it's about 2.5 hours. Now, I told you the train ride takes 2.5 hours. That's because this graph is graphing the average speed of the train. My train, however, maxed out at 302 kilometers per hour. So we're going to use the conversion rate that every mile is 1.61 kilometers and figure out how fast that is in miles per hour. Here's how we'll do it. I know that the train was traveling 302 kilometers. Hold on. That's not what I want to do. Let's start with this. Let's make it make more sense. Let's start with that ratio. If 1 mile is 1.61 kilometers. How many miles would 302 kilometers be? Now, you might be thinking, why do I care about the distance? I just want the speed. Because I was traveling 302 kilometers per hour. So if you can tell me what 302 kilometers is in miles, well, that would be miles per hour then. So we cross multiply. 1.61x. Seth, I'm going to call on you on this one. I'll let you do it. 1.61x is equal to 1 times 302, just 302. Seth, do that division for me and tell me what you get for x. The pressure is mounting. Everyone's anticipating this answer.
187.
Round to 1 decimal place. 0.6. And that would be miles. But since it was 302 kilometers per hour, I'll call this miles per hour, or mph if you'd rather write that. And that is very fast.
Yeah.
Okay, that was the maximum speed, 187.6 miles per hour. That's NASCAR speed. Okay.
A car can go that
A
fast.
car can, NASCARs can. Indy cars can go up to 200 and some miles per hour, so they're faster, but this is NASCAR speed. And so now,
Let's all buy a NASCAR car. And then we'll
Now I will show you.
Going at the max, going at max speed. That's definitely not dangerous at all.
Like, just down your street, a go-kart going 327
What is
going up there? What would you do if that happened? In that
You run to
situation,
the
it's
other
like
side,
a go-kart,
bounce it out.
127 miles per hour. coming for your house.
You should have probably.
We have to stay there. It's just like that would be
So that's an actual picture.
Yeah.
That's a whole lot to that. I thought you said both.
Everywhere, except for
I got excited for it.
the law.
I don't know if I can get this to record it.
It's like a series of.
9:14.
It's like this internet thing, it's like a series of songs.
What year was
made
that?
Like action.
All right,
Wow.
that's what it looks like.
Oh my God. That looks like so much fun if it was a roller coaster.
No.
Yes, imagine if that was a roller coaster. That would be amazing.
So if it's all about perspective, right? Because if you look out there, like, well, those mountains aren't going by too fast, but those are way out there. And so the stuff that you see flying by real quick, those would be like the equivalent of the telephone poles that you see when you're driving down the road. Except this time they're traveling by this quickly. Yeah, so and the crazy thing is it's a very smooth ride. There was like a snack car where you can go and you can get little snacks and stuff. You can get drinks and everything, like pop and bottled water, all that stuff. And so you can get up and move around the train freely because it really is super smooth. You don't even hardly realize that you're moving, much like a plane. You don't actually feel like when you're, well, you feel turbulence on the plane,
Does
obviously.
it,
But
does it go straight? Like, does it
it for the most part, it kind of does one of these things. It takes you up north and then it takes you over.
Does it slow down to make the turn, or does it just
I think so.
shoot by?
No,
It doesn't
it's only going to reach its maximum speed on a straightaway, which is why that chart had the average speed of 200 kilometers per hour.
If only it just went max speed the whole time.
Right?
It's not dangerous at all.
Okay. So let me take this off.
Just laugh in the face of death.
What's your question?
If you jump, you go find that.
If you were on top of the train, yes. Inside the train, no.
No, you would go, how does that work?
Yeah, how does that work?
How does that work? Well,
Is
when
it
you're
airtight?
when you're in the train, I don't know all the science behind it, but if you're in the train, everything's moving with you. But if you're out of the train, you jump, it's only the train that's moving and you're not. That's the non-scientific way of me describing it. So,
Yeah, but if you're in the middle of the air, that is still going.
I'd really like to finish. Okay, we got 4 minutes left. Let's finish this last problem. Here's another graph. Would I be correct in saying that this is not a proportional relationship?
No.
No, it is. Yeah, so it gives you a preview of tomorrow's lesson. This is a proportional relationship because it goes through that point that Jimmy mentioned, the origin, 0, 0. I did this because I showed the other classes that Abe video, and then I forgot that when you do that, it apparently makes AirPlay go to the other screen. So let's see now if I can get this to share.
Yeah, it's not there.
But I also have to share it on my Zoom too.
We don't care about that.
Well, of course you don't.
I hope they do.
Okay, it says the graph shows the toll Y on a turnpike for driving X miles. Turnpike would be like a toll road. And so it says your toll is $6. How many miles did you drive? Well, if I look at, well, I can use any of these points except the origin. You can't use the origin because the origin doesn't give you any information. Of course, you're not going to pay anything if you don't drive on it. So there's no information given there. You also can't divide by 0 for finding a unit rate, but I can use one of these 2 points. I'm going to use the one that doesn't have a decimal. And I'm going to use the one that says that if you drive 200 miles, you have to pay $15. Make sure you know what each number stands for. 200 is the X number, it stands for miles. So if I drive 200 miles, I will pay $15. Because we're in a section titled proportions, I'm going to set up a proportion and say that if I pay $6, I'll match that up, should go on the bottom, I would then be driving how many miles? So the first rate comes from the graph. I pay $15 for 200 miles. The second rate I'm creating and plugging $6 in so I can try to find the number of miles we drove. So what's 15 times X? 15X. What's 200 times 6? 1,200. Divide by 15. Sky? 80, what? 80 miles. Exactly. It's not a unit rate, so it's not 80 miles per dollar or anything like that. It's just 80 miles. It's actually 80 miles for $6. It says, how much does it cost to travel 260 miles? Well, I could use the same point, but I'm feeling risky and I want to use the other one. So that means I'm going to drive 100 miles and pay $7.50. That's where the 7.5 is coming in. So if I drive 100 miles and pay $7.50, then I would drive 260 miles and pay what? So I cross multiply. 100 times X is 100X. Someone tell me what 7.5 times 260 is. 1950. Divide by 100 means moving the decimal backwards how many spots? 2. And you should get $19.50 for those 260 miles. Last question says, how much does the turnpike cost? This is something that Lizzie would do because Lizzie did the same thing earlier. You would take 100 miles. Well, hold on. Miles per dollar or dollars per mile? Dollars per mile. Let's do 750 divided by 100. Move the decimal backwards 2 spots and you're going to get, hold on, that's too many zeros. You're right, it's only 1. So basically 7.5 cents per mile. I guess you would round it to 8 cents per mile, but we'll say 7.5 cents per mile.
8. Oh my gosh, that seems
Right? Wouldn't you round it to 8 cents per mile? That's not bad.
Yeah, that seems.
I paid a lot more when I drove on Florida's Turnpike this fall break. So you guys are dismissed. Have a great day.
What?
It's interesting, when you drive on toll roads, they don't even make you stop anymore. They just take pictures of your license plate and send you a bill in the mail.
Yeah.
Like we got a bill 2
That's
weeks
what
ago.
happened to
They're like,
us.
you drove through this toll. There's a picture of our car, their license plate. Well, I can't deny it. So then we got a picture of me.
That's what happened to us. Like we didn't get any charge, and then a few months later.